Most AI engineers make a fatal mistake on day one. They marry a vendor. You write, import OpenAI. You hard-code GPT-4. Congratulations, you have just created technical debt. But it's worse than that. You've created a single point of failure. What happens when OpenAI has an outage? Your app dies. What happens when DeepSeek releases a model that is 10x cheaper? You can't use it without rewriting your backend. This is not engineering, this is dependency hell. Today, we fix this. We are taking back control. We are building the universal router using the adapter pattern. In software engineering, this is known as the adapter pattern. It is one of the most powerful structural patterns in distributed systems. We place an abstraction layer between our application logic and the intelligence providers. Think of it as a universal translator. Your app speaks one language, the router translates it for OpenAI, Anthropic, or DeepSeek. The pros are massive: zero refactoring. You can switch models by changing a single string in a config file. Uptime: if one provider fails, we automatically route to another. The cons? A microsecond of latency. For 99% of production applications, this trade-off is a no-brainer. Let's build it. We start by installing LLM. This library is our secret weapon. It normalizes inputs and outputs across 100 plus LLMs. Now, look at lines 5 to 9. We define a model registry. We don't think in brands like GPT or Claude. We think in capabilities. Fast, quality, cheap. This is crucial. Fast might be Llama 3 today, but it could be Haiku tomorrow. By decoupling the capability from the model ID, we future-proof our application against a rapidly changing AI landscape. Now we implement the router. We create a function called universal_chat. It accepts a user prompt and a capability flag. Watch closely. We resolve the model alias from our registry. Then, we call the universal completion function. I can run this with capability equals cheap, and it hits DeepSeek. I change it to fast, and it hits Grok. The code structure remains identical. This is the definition of clean architecture. But we're not done. This is where we leave the junior engineers behind. In production, APIs fail. Rate limits get hit. Cables get cut. If GPT-4 times out, your user shouldn't see an error page. We add a fallbacks list. Look at the code. We tell like LLM, try the primary model first. If it fails, automatically retry with GPT 3.5 Turbo, then Claude 2 Foot. This happens seamlessly in the background. Your user never knows there was an outage. This guarantees high availability and keeps your SLA green. This isn't just a script. This is a resilient system. You have built the interface. You have decoupled your logic from the vendors. You have a system that is resilient, flexible, and ready for scale. But an interface needs a brain. In day 2, we are going to rip open the black box. We will build a transformer block from scratch in PyTorch to understand how these models actually think. The full code for this router is linked in the description below. If you want to survive this sprint, make sure to follow and subscribe. See you in day 2.